Hi everyone. Today the topic is WASM, WebAssembly. Anyone heard of WASM, WebAssembly? Anyone? Okay, I can see some hands raising. First of all, I need to give a big shout out to our organizing team actually. So organizing this kind of a conference or community meetup, it is not going to be a easy one. So it is kind of you need really real hard work, dedication, and passion. So thank you very much, and I'm honored to be here as well. Thank you for inviting me as well. Right. So that's I wanted to mention that first. Okay. So this is some information related to myself. So if someone who might not know me, I'm Nimesha, right? So currently working as a software engineer for Code Cloud in the DevOps and site reliability engineering field. And also, this is so much crowded because I do a lot of stuff, right? So I am a top rater plus freelancer in Upwork platform. And in my career, I have spent more than 5 years as a full stack software engineer at IFS. I was working with front end stuff like React.js and also middle tier stuff with Java and also Oracle in the database side. And also apart from that, I am a hobbyist YouTuber. So I'm giving kind of a marketing here for my YouTube channel as well, right? So, and apart from that, I am doing some of these Python lectures in elearning.lk, one of the Sri Lankan e-learning platforms, right? So many things because I like to share knowledge. I like to interact with people. I like to share I like to talk with people, and that's how it is. Okay, so let me move into the today's topic. So I'm going to do something interesting today. So what I'm going to do is I'm going to run a C program within the browser. Can we do that? Can we run a C program in our browser? Like inside Firefox, Safari? Can we do that? Anyone? Okay, let's see this in action, right? So what I'm going to do is, I got a basic C program here. This is just a simple C program. What it does is it prints out hello KCD Sri Lanka to the console, right? To do that, what we are going to do is we are using this GCC compiler. So using GCC compiler, we can give the source code, and then we get the output as an executable, right? So then we got this executable, and it can be executed in your machine, right? So we get this output. So I am not going to run this one because everyone knows it, because I know these are software engineers, right? So everyone knows how to run a C program, right? If not, you need to think about that, right? Okay, today what I'm going to do is, I am going to use the exact C program, right? Exact C program, but I am going to run this inside Safari or Firefox web browser, right? To do that, I am not going to compile using any GCC compiler. I am not going to use any of this, right? I am going to use something called mscripten, EMCC, right? What it does is, it will turn your C program into a format that browsers would love, right? So we'll do that. So I am going to open my Visual Studio Code here. Okay. We got Visual Studio Code here open. So this is the simple C program which prints hello KCD Sri Lanka. So what I'm going to do is I am going to run this EMCC hello KCD.c. This is the source program, and the output is going to be a HTML file, .html file, right? Not a just executable as we see in the normal C program execution, right? So I am hitting on enter. Okay. Now we got several files generated here. But what I am going to do is, first I am going to open up this HTML in our live server here, right? So I am going to open up here. Okay, now what you can see is, hello KCD Sri Lanka is printed, and don't worry about all these CSS styling and other EM script and logo and all this stuff. Just focus on the message, hello KCD Sri Lanka. So this is coming from our C program. So if I go to the Visual Studio Code again, so here there are something called hello kcd.wasm. So this is what we called as wasm module, right? So what we do is we generate this wasm using this mscript and emcc command, and then however we include that in our HTML. So I will show you that as well. This is generated code. So there are a lot of code there. So in this HTML, if you check this source here, right? So here we got hello kcd.js file, right? If you go to this JS, this is where we include our wasm module. So this is where we use our wasm module, and that is how the output has came through, right? So I just wanted to give you some kind of a background or some kind of introduction what we can do with wasm, right? So let's go back to the presentation and let's see what we got there, right? Okay, so welcome to the wasm, and before moving into the slide, I should say, since we got very limited time, I need to share some of these resources with you as well. This is a YouTube video which is related to WebAssembly. Me and Mumshad, we had a discussion a few months back, and we thought that we should release some kind of a video related to WebAssembly, that because at that time there was no any good WebAssembly related videos. But this is a really good video. Please go to the YouTube and check this out. This will give you some kind of a background regarding what is WebAssembly and what is the difference with wasm and Docker, right? And also I am writing many blog articles related to WebAssembly. So this is one of these articles I have written, WebAssembly versus Docker. So this is again in the top search results in the Google. So you can search this. So there are many resources out there. I am showing these because you can just go and check this out, right? Okay, let's move into the presentation. Yeah, so who is wasm? What is wasm? So that's the first thing that I need to explain to you. So WebAssembly is binary instruction format. So what is a binary instruction format? What is a binary instruction format? So binary instruction format is it is some kind of a representation of code, right? That can be stored in a binary format that, you know, computers can understand binary, right? So that is what we call as a binary instruction format. So it is a binary instruction format and allows code written in languages other than JavaScript to run in the browser. So that means you don't need JavaScript anymore. I mean, you need JavaScript. I mean, you don't need to rely on JavaScript to run some logic in browser window, right? So you can use wasm instead of JavaScript, but you still need to work along with JavaScript. But wasm is there to back you, right? So then at near native speed, this is something really important. What is near native speed? So near native speed means, it means you can run these programs, performance of those programs is almost as fast as if the code was executed in the computer's hardware, specifically the CPU, inside the CPU, right? So this is what is wasm. This is what is WebAssembly, right? So yeah. So if you go to the, if you check the definition in the internet, you will see a very big definition there. But basically, it is all about a binary instruction format, and it can run in a near native speed, right? Okay. So let me move into a simple illustration here. This is what has happened when we run our C program in the previous demonstration. We got the C code, and we have used this M script and compiler to compile this C program into a WASM module. Then we got a .wasm file, that is the WASM module, right? Then we have ran that along with JavaScript code, right? That is what you have seen this in the browser window, right? The output. So this is simple illustration. I just wanted to show you how everything works together, right? Okay. Now WebAssembly is this is you know the WebAssembly is there are so many discussions around WebAssembly these days, right? And after the containers, I think WebAssembly is the most revolutionary thing in future, right? So there are reasons. There are some reasons for that. So these are the reasons actually. These are the things. This is the strength of WebAssembly, right? So first thing is performance boost. So I have given some kind of introduction to this. You know, since WebAssembly is a binary instruction format, it is almost like machine code, right? So you can run it in near native performance, right? So that's the first thing. Then the language flexibility. So the language flexibility means, let's say you don't know JavaScript, you don't know how to program with JavaScript, right? But you know Rust or C or C++, right? So you don't need to know JavaScript to run, create your new web application. You can use your existing C or C++ code, and that can be used in web now, using WebAssembly. So that's what we call as language flexibility, right? That is another major reason why this WebAssembly is important, and one of these strengths in WebAssembly, right? Then the security aspects. So usually WebAssembly runs inside a sandbox environment. So sandbox environment means it is isolated from the host machine, right? That means WASM modules can't access host machine's arbitrary memory and files, database, totally isolated from the host machine, right? So there's a good security when it comes to WASM, right? So then we got this portability. You know, portability means when you have this WASM binary format, you can run it in anywhere, in any platform, right? If you have the WASM runtime, if you have the proper WASM runtime, you can run it in anywhere, right? So then the browser support. So browser support is, you know, when it comes to WASM, now almost all the major browsers are supporting WASM, like Chrome, Firefox, Safari, and Edge. These are supporting WASM. So you can test this out. And the expansion of web capabilities, right? So it is again, let's say you have a web application that is that goes with heavy computations, right? Like as an example, let's say these Figma or CAD, these involves heavy computations, right? So in that case, JavaScript is not the optimal language. You know, JavaScript is interpreted, right? But the C, C++, those languages are compiled languages. Normally, compiled ones are faster than interpreted ones, right? So in that case, if you can write your logic in C or C++, and you can run that, or you can port that code into your web application using WASM, that is where the magic happens. You can do, there are many ways you can do heavy computation related stuff, right? So then the growing ecosystem. So growing ecosystem means actually, when it comes to WASM, I will show you something. So I got a slide here. So this is a WASM landscape, right? This is a WASM landscape. So you know, maybe you guys are aware of the cloud native landscape, right? And if you go to this site and the CNCF site, and if you check this WASM tab, this is a WASM landscape. Check this out, check this whole thing, right? How many, I mean, look at the languages. You know, in these days, even new languages are, native WASM languages are implemented by the community, right? And many runtimes and frameworks are coming, like WASM Cloud, you know, the Spin. Those are the application frameworks that can be used with WASM, right? So please go to the CNCF landscape and check this out, the WASM landscape. So there are many things, so really cool. I mean, you can learn many things, right? Okay, so let's move back to the next part. The WASM outside of browsers. So now I have shown you how can you run your simple C program in browser, right? But that is not the only thing we can do with WASM, right? We can use WASM even in backend, right? So I will show you a simple demonstration. Since we got this C program already compiled into a WASM module, what I'm going to do is, since we got this JS file generated, this imports this WASM module. So what I'm going to do is, I am going to run this WASM module inside a Node environment, right? So let me check whether I have Node. Yeah, I got Node. So Node. Yeah, I have run this node, this one, the node hello KCD.js. So it is running. Hello KCD Sri Lanka is coming from that C program, right? Not from the JavaScript, right? It is that logic is written in the C program. That is tagged as a WASM module, and then we have run it in a node environment. That's what has happened here. So it is not only limited to browsers now. It is going to this cloud, right? Yeah. So next thing is WebAssembly versus Docker. So now some of you might be confused about, I mean, what is what is the difference between WebAssembly and containers? Or are these similar? Or WebAssembly is better than containers? So likewise, you might have some questions inside your mind, right? So let me clarify this one. So normally, you know, containers are those are containerization platforms designed to package and distribute your applications across different environments. So you all know that because these are container experts, I guess, right? So you know what are containers. So when it comes to WASM, WASM is not like containers. It is not even a programming language, right? It is a binary instruction format, or it is a compilation target. So let's take an example. You know Java, right? You know Java. So when it comes to Java, if you compile your Java program using Java C, it is converted to Java bytecode, right? It is one example for compilation target, right? So likewise, WASM is another compilation target or binary instruction format. So if you go through these two figures, you will get some kind of an understanding what are the differences. So let me move forward. This is a small comparison of WebAssembly and Docker, right? So in this case, if you check the size-wise, WASM is several megabytes. WASM module is several megabytes, but when it comes to container, it can be hundreds of megabytes, right? Because you know, and even check this startup times and performance speeds, right? WASM millisecond startup times, containers are seconds, because containers are, what this says is, WASM is faster than containers, right? In this, if you check this cross-platform and portability aspects, WASM is high because it is a binary instruction format. It can run at anywhere if we have the WASM runtime, right? So when it comes to containers, it is specific to CPU architectures. You know that if you need to create a Docker image, and if you need to run it on a Linux or Raspberry Pi, you need to go with ARM, right? So it depends on, right? But when it comes to WASM, if you have the WASM runtime, you can run WASM modules, right? So that's the strength, right? Okay. So the time is, okay, let me go through these. Next, I am going to discuss about the integration of WASM and Docker. So I told you now, WASM and Docker are two different things, but nowadays, you know, WASM containers can be ran inside Docker, right? WASM containers can be ran inside Docker. So that is something, that is another topic actually. So I don't think I have time to explain each and everything, but check this out. Docker is usually we use for packaging code, and it has high portability and runtime isolation. And Wasm, it is running with near native performance, and it has high security and quicker startup times. So what if we combine those features together? And that is where Wasm and Docker combination works, right? So it is actually, please go check this out. There are many resources out there. Please check this out. So I am just giving some kind of a hint for these things. Okay, the final slide, I am going to give you some examples to real-world applications on Wasm. As I mentioned, these days the Figma, it uses WebAssembly to boost the performance of its web application, right? And also Autodesk, this CAD software, it also uses WebAssembly to boost the performance, right? And one thing is this Epic Games, the Unreal Engine. So they are using WebAssembly as well to gain the performance boost, right? So that is how Wasm works, and what is going on with these products, right? And this is about Wasm landscape. I have gave some kind of an introduction to this. Yeah, so that's all about today's presentation on Wasm, and I think I have given you some kind of a background and introduction to WebAssembly. So now you can go home and check this out. Check these blogs, check these articles related to Wasm and also what is the difference between Wasm and Docker. So please check these things out. Really interesting. I don't know whether I made this complex. I don't know whether you will not. I don't know. So but just try this out. All right? Okay. Right. So that's all about my presentation. So thank you, and thank you all for inviting me here. Thanks for.